This is our motion radar robot. We have two PIR over here, one photodiode and 3 IR transmitter. Yeah. Demonstrating on how our motion radar robot works. Okay. To the left, to the left. To the right. This is our code for the motion radar robot. First, we include the library of the servo motor and the library of LCD display. We set the name of the servo motor to MPU, and then we have pin 9 for the input of the servo motor, and we limit the angle of the servo motor to 180 degrees, 90 left and 90 right. Then we set analog pin 2 for the left PIR and analog pin 1 for the right PIR. And for the proximity sensor, we use the analog pin 0. And we set the pin 1 for the IR emitter.
For the anode.
To the anode of the IR emitter. Yeah. Left, right, no distance. Ito yung ano. Output, our output pin.
We set
the
pin 1 as output.
Pin 1 as output pin for the IR emitter. Input pin 1 and 2 for PIR left and PIR right. And this is the part of our loop. This is read the value of the left PIR, and this is the statement for the right PIR dito. This is the part of the if statement for our loop. If left sensor is on and right sensor is off, the angle will increment by 1. And then the current angle to the servo.
Kita mo ba? Wala pa sa amin. Parang hindi mo mabasa.
This is the part of the code for the if statement. If left sensor is on and the right sensor is off and the angle is less than 150, the angle will increment by 1 and it will rewrite the angle with the new computed value. And in this part is for the right sensor. If left sensor is off and right sensor is on and the angle is greater than 30, the angle will decrement and it will rewrite this part with the new angle. Right. And this is the if statement if the right and left sensor are equal in value. If they are both off, it will start to measure the distance of the object from in front of the robot. Yeah, it will scan and will compute.
if the reading of the both sensors are equal, then it will go to the next line, distance equals scan quantity 5. So the value inside scan will, the greater the value, the more accurate the reading will be. Then we declare scan as a float, and the number inside of it will be equal to times, and the variables that's used for the measuring of the distance is here: integer total, and the ambient, which is an array that has a size that is dependent on the number inputted on the times, also the object array and the value array. So for integer x equals 0 and x is less than times, it will increment. First, it will turn off the IR LEDs, and the Arduino will read the value at analog pin 0, and it will store in the array of the ambient. Then after a 50 millisecond delay, the Arduino will turn on the infrared LED, and it will store that value to the object array. Then after those, it will also again count up to the number of times, and it will compute for the difference of the two values, the ambient infrared and the object infrared. Then for another counting, it will count up the total difference, and then it will get the average for better and precise accuracy and precise reading of the infrared. Then it will return the value to the main loop. Then next is the new distance equals to convert. This will translate the obtained IR difference to its corresponding distance. Then this is the code for the convert. First, the integer sensor min max. Then when we tune the infrared, the photodiode, we found out that the response is not linear, so we have to divide it by 3. If the IR difference measured is greater than or equal to 55, it is between 0 centimeter and 1 centimeter. Also, take note that the photodiode can only measure up to 5 centimeter. Next, if the IR difference is between 59 and 33, this will be the values of the variables. And if the IR difference is less than or equal to 33, this will be the value of the variables. Then we use the function map to obtain its corresponding distance. For better accuracy, we divide it by 1000 because the map function only produces an integer number, so we need to multiply it by 1000, then we'll divide it to 1000. Then it will return the value to the main loop, and it will display it to the LCD. And that's it. The loop will go on forever and ever.